Alright, so we have a problem. The roller coaster does a loop-the-loop. The circular track is in radius of 8 meters. What speed should the roller coaster have at the top of the loop to make the passengers feel half their normal weight? So first step is to draw a picture. And in our picture, we want to draw a free body diagram so we know what forces are acting on us. So we have a force of gravity, is our first force. And our other force is going to be a normal force in the downward direction because the seat is pushing down on us.
Alright, so after our free body diagram, we can come over here to Newton's second law. Newton's second law states that the sum of the forces is equal to mass times acceleration. In our free body diagram, we had two forces, the force of gravity and the normal force, which are both acting towards the center of the circle, which we'll label as positive. So here we have the force of gravity plus the normal force is the sum of the forces. You know that gravity is equal to mass times gravity. And we know that the normal force is going to be half the force of gravity. So we have mg over 2, and these two together equals 3 mg over 2. Over here we know that our acceleration is equal to mass times the velocity squared divided by the radius of the circle. So we have mass times velocity squared over the radius equals 3 mg over 2. If we cancel out the mass, we have velocity squared over the radius is equal to 3 times gravity divided by 2. We bring the radius to the other side, and you have the velocity squared equals 3 times gravity times the radius of the circle divided by 2.
So with the formula we get here, we can put a square root over everything here to find velocity. That gives us v equals square root of 3gr over 2. And then we can plug in 9.8 for g, and then 8 for r. That gives us the square root of 117.6, and then square root of 117.6, that's 10.844. And then you put in meters per second at the end because it's velocity.